802.11ac is the next generation Wi-Fi standard from the IEEE, defined for 5 gigahertz devices. It introduces a number of new techniques. 256 QAM, which is a very advanced modulation encoding technique, which basically quadruples your physical layer data rate. Channel bonding in 80 megahertz and 160 megahertz channels, as well as a new concept of multi-user MIMO, where an access point can actually communicate simultaneously with multiple client devices. .11ac will provide some benefits in the enterprise market. Probably the biggest benefit actually is the fact that it's just 5 gigahertz only. This will of course cause a lot more devices to support 5 gigahertz, which is a very capacity-rich band. It's currently a lot of smartphone devices and devices of that class are only in the 2.4 gigahertz band, and that causes a lot of problems when you have a very high density type of deployment, like in an event center or a conference center, for example. Having 11ac proliferate out to all these devices is really going to dramatically increase the capacity that you have available in these dense type of environments. One of the things 11ac isn't really going to be wonderful for, there's a lot of talk about this gigabit Wi-Fi, and these are mostly a gimmick using these 160 megahertz channels, primarily targeting consumer retail type applications. In the enterprise, that's not really very interesting. It's kind of a zero-sum game. You're increasing the peak speed, but you're taking capacity away from other APs. So it's really not very interesting. 256 QAM, maybe very limited applications in some cases. You might get a little bit of an interesting bump, but it's kind of a you're making the best case better, but the majority of the cases aren't going to get any better with 256 QAM. Turns out with the multi-user MIMO, the antennas come back into the forefront. Multi-user MIMO is a technique where you have, in the 11ac standard, up to 8 transmit antennas talking to clients simultaneously, potentially up to even 8 clients simultaneously if they're all single-stream devices. Since most mobile devices like handsets and even tablets are single-stream devices, having the ability to communicate with multiple of them simultaneously will increase the overall capacity. The trick here is that the magic is all in having very good antennas and very good properties for those antennas. Omni antennas sticking out of this AP like a porcupine probably aren't going to get the job done like people expect it to be. People want internal antennas, they want them to be low profile, and they want them to have good characteristics whereby you're getting the full benefit of this advanced technology that you're paying for. And this is really the sweet spot of what Ruckus has been able to do over the years, is optimize antenna structures, optimize them specifically for the PHY modes that we're trying to enable, and doing that in a low profile, attractive form factor.